Imagine if there was no clean water on the planet. This situation would probably suck, and no one would like it. Not the plants, not the animals, definitely not the people. So this got me thinking, what could I do, even in a small way, to help a situation like this? And I created a Raspberry Pi project, water monitoring project as a result. And in this video, I'm going to showcase how it works and what it does. So without further ado, let's get started. The brain of the system is the Raspberry Pi. It reads the sensor data, processes the information using a Python program, and displays the results on a local website. Now I will talk about the sensors. The first sensor is the pH sensor. The pH sensor measures how acidic or basic the water is using a special glass probe. The probe produces a tiny voltage that changes depending on how many hydrogen ions are in the water. More hydrogen ions equals lower pH, while fewer hydrogen ions equals a higher pH. The second sensor is a TDS sensor. The TDS sensor measures dissolved solids. The sensor sends a tiny electrical signal through the water between electrodes, and water with more dissolved solids in it lets electricity pass through more easily. Then the volts are recalculated to ppm, meaning parts per million, using the proper equation. The third sensor is the turbidity sensor. The turbidity sensor measures how clear or cloudy the water is. It shines a beam of light through the water and measures how much of that light gets scattered or blocked by floating particles. The pH, TDS, and turbidity sensors are analog sensors. Since the Raspberry Pi cannot directly read analog voltage, these sensors are connected through an analog to digital converter, which in my case is the ADS1115. There is also the temperature sensor. Unlike the analog sensors, the temperature sensor is read directly by the Raspberry Pi. Because it sends a digital signal, I don't have to convert the voltage manually. The program reads the value in Celsius and can convert it into Fahrenheit if needed. So now I will be showcasing the real-world assembly with all 4 sensors. And 3 of these sensors connect to the converter, which is right here. And the temperature sensor connects to the Raspberry Pi, right here. And the Raspberry Pi is going to connect to the monitor, which is right here. Now I will be showcasing the code that I used for the Raspberry Pi. So if I go into this terminal and type in this command right here, you have the parameters listed first right here. Then as you scroll down, you have the conversion from voltage to the actual values. Then it's called in this command. Then this is what shows up on the website itself with the values. Then if you scroll down, there is the HTML, so the design of the page, along with the CSS. And then if you scroll down further, everything is called in this command right here. And you can read about this more in depth in my GitHub link, and it will be in the description below. So moving forward, if I type in this command, it shows the IP address, and now it should display on this computer right here. So if I click the reload button, it should show this page right here, and this is the whole website. And it can also run on phone. So if I go to phone and I click reload, here it is on my phone as well. Now I will demonstrate how my sensors work. Starting with my pH sensor, I'm going to be showing how it responds to different pH solutions. So first we're going to use a pH solution of 10. And 8.59. It needs to stabilize a bit. So maybe if it goes, yeah, then it's getting closer to 10 as it stabilizes more. Now back into the water. Now we're gonna do 4. And then it's gonna be approaching 4. Next, I will show the TDS sensor. For the TDS sensor, I will first use a clear glass of water. And I need to wait for it to stabilize. So 118 ppm. Now, I will add salt to this water and stir. Now I will put it back in. Now this one has a way higher BPM than the one that was clear. Next, I will show the turbidity sensor. For a turbidity sensor, I will again use clear water. And it shows that it's clear. Then, this time, I will use flour. So, 1 spoon. I will mix this, let it get cloudy. And then I will put the turbidity sensor in it again. And this time it says very cloudy. Finally, I will show the temperature sensor. For the temperature sensor, I will use regular water, room temp. And it's showing normal temperature, 24.12 Celsius. And then I will use ice cold water. And now it is showing 18.81, and it will probably go lower. Yeah, 15.12. And 12.44. So now I will be showing the assembly for my water system that I will use for my project. And these are pretty basic parts. You can find them at like a Lowe's, Home Depot, maybe a construction store near you, anywhere that's available. And I'm just going to quickly assemble this. And normally for the test, I would use like clay right here and then attach it to these pieces right here with this cement. But I'm just demonstrating it right now and I'll test it later. And these parts would normally go over here and they would connect to the sink, to the hot water. And this one would connect to here in the whole waterway of the whole house. But I'll do that later as well. And also there are 4 holes right here, with the biggest one being the turbidity sensor and the other ones being for the other sensors like the pH, the temperature, and the TDS. Okay, so for the final part of my water monitoring project, I'm going to be in the bathroom because I'm going to be using my water system, which is connected to the sink. So moving down here, we have the Raspberry Pi, which is attached to a metal box which contains the electronics. And then the Raspberry Pi connects these 4 sensors that are connected right here and glued to the water system. And the water system has 2 valves, one of which is connected to the hot water, which is from the house's water. And that valve goes into the canister, which is currently empty, fills it up. When excess water is produced, that goes into here, which goes up here. And when you turn this, it's going to be flown out of the sink. So then that's all going to get displayed on this monitor, which currently has default values. And let's get started. So first we're going to turn this, and then we're going to slowly take this and turn it this way. We're going to turn it slowly. Okay, now it's slowly turning, and the sink should be gaining water. Not as of yet. So now it's starting to flow right here. And if we check it, we can see 186, normal, slightly cloudy water. It's a bit too alkaline, and the temperature is normal. If you wait for it to stabilize, maybe the pH levels will stabilize a little bit more. So overall, I would say it's a pretty good run. I would say it's a success. Okay, so that's been it for my water monitoring project. And honestly, I think it turned out pretty good. If you want to, feel free to leave a like and subscribe. That's if you want to, of course. And that's been it. Thank you for watching.